So therefore, in continuation to my previous class, I am discussing few models related to the law of conservation of linear momentum. In the law of conservation of linear momentum, I told n number of times the particle momentum is conserved only when there is no external force. Now you have a situation here, block of mass m is pushed with a velocity v0 along the surface of a trolley car of mass capital M. If the horizontal ground is smooth and the coefficient of kinetic friction between the block and the plank is mu, find the minimum distance of relative sliding between the block and the plank. See, you can consider the situation almost like this. Imagine a plank whose length is bit long, and this is a smooth horizontal floor, right? And I have projected a block onto this. I have projected a block onto this with a velocity v0. Now, please try to understand in this situation. Initially, the lower part is rest. Fortunately, I have one facility is that this part is smooth. That is a really big advantage for me. Now, what will happen in this case is that, for example, at some time later, the block will get v1 velocity. Plank also gets v1 velocity. Then, yes, tell me, someone was trying to reach me, right? So now both will have common velocity. You know, this class is being recorded. You can see this entire part if required later also. Now, what is happening over here, I have clearly mentioned. But remember, there is no external force here. Don't question me about the friction between the block and the plank. They are internal forces. There is no external force. Here, momentum is here. Law of conservation of linear momentum can be applicable, which gives me mv0 is equal to small m plus capital M v1. This is the first observation. Actually, with this, the chapter is done, right? You want the minimum distance of relative sliding. Yes. Now, from here after, you apply it in terms of C frame of reference. In C frame of reference, initial kinetic energy is, you know, I am using a word called mu. Okay, I cannot use mu because you'll get confused with friction here. M reduced mass. M reduced mass is nothing but small m capital M by small m plus capital M. So in C frame of reference, this is small m capital M by small m plus capital M V naught square. This is the initial kinetic energy of the system. Remember, I am applying law of conservation of energy in case of C frame of reference. Finally, when they both have a common velocity, the kinetic energy is 0. Plus, you are doing work against friction. So the energy what I had initially is totally lost to do work against friction. Right. Okay, right. No issues. You want the minimum distance, right? This is half small m capital M by small m plus capital M V naught square is equal to friction here is mu mg. I know that. Friction here is mu mg and S relative. That is what they are asking. So which implies S relative is equal to, you can cancel this M, half mu G times capital M by capital M plus small m times V naught square. This is your answer. Sir, what is the role of this question in this particular chapter? Nothing. If you want a common velocity thereafter, after that they will commonly move with mv naught by capital M plus small m. That's all. Only for that purpose you have this. Otherwise, this will come under center of mass chapter only. Right. So can I consider that you followed this? Manideep, have you understood this question?
Yes, sir.
Right. Varun,
Yes, sir.
right. A simple question actually. Next question. Block of mass M1 is projected with a velocity V naught, so that this is a standard problem. In fact, even in mains exam, original mains exam also, you are expected to have this question n number of times, repeated number of times. Okay, now you have projected this block on a special wedge like this. If the block does not leave the wedge, find the maximum height attained by the block. Now, what is happening over here? Initially, this is the condition. Now, see, two things will happen. Two things will happen. See, in this, that's all. V naught, M2, this is the initial situation. Right. I can say that this is the initial situation. The final situation is like this. The block will reach here. Remember, the entire system will now have velocity V1. Both will have V1 and no vertical component of velocity for the block. Block 0. Vertical component is 0. And this we will call as the final state. The final state. And by the way, this is height h. Actually, even now also, momentum is conserved along x-axis only. Why? You cannot conserve momentum along y-axis. Anyone in the class, can you please answer this? Anyone in the class? Why cannot Tejaswini Chaptava? Why cannot I conserve momentum along y direction?
సార్ ఎంజీ యాక్ట్ అవుతుంది కదా.
Right, correct. Since there is an external force acting, you cannot conserve momentum, linear momentum along y direction. But you can conserve linear momentum along x direction. Linear momentum is conserved. Only along x axis. So therefore, I can say that m1 v naught is equal to m1 plus m2 times v1. Okay, right. Now you do the problem in C frame of reference. Initially, my kinetic energy is nothing but m1 plus m2 v relative square. I think you remember this relation. Half m reduced mass v relative square. Area second one is already rest. So therefore, in C frame of reference, this is the condition. I don't know how many remember this. See, please try to refer that particular notes once. Here it is. Now we have done C frame, center of mass reference frame. So kinetic energy in center of mass frame is half m1 m2 by m1 plus m2 times v relative square. And what is the conversion factor? If we for two such particles like this, for two such particles, when someone see in ground frame, this is the kinetic energy. When someone see in the C frame, this is the kinetic energy. And how are they related? This is the relation. So this is well discussed in C frame of reference. Now we are moving back to our law of conservation of energy. That's what I'm applying in C frame. This is the energy what I see. And finally, when both are having same speed, kinetic energy is zero. What happened to the entire energy? The entire energy is now is in the form of potential energy, mgh. Therefore, clearly, h is half v naught square by g times m2 by m1 plus m2. That's the height. That's the height. So this is the maximum height that you are expected to have in the case of what do you call the block and the wedge system, right? So any students having doubt on this, please ask me. Any students, right? Abhinav, have you understood? Anika, are you there in the class?
Understood, sir.
Have you understood?
Yes, sir.
Right. We'll move on to the next question. Next question is also a similar one. Two ring of one is M, the other is 2M. They are rings. They are connected with a light spring. We have done a similar question in VAT yesterday. But that is a thread based, this is a spring based. And you have two parallel rails. Right. This ring is given V naught speed. Calculate the maximum stretch in the spring during the subsequent motion. See, please try to understand, when do we say that the spring is under maximum stretch? Simple. Suppose at some point of time, the spring is under maximum stretch. You know what happens that time? This will attain V1 velocity and this will attain V1 velocity. In this case, the spring will not stretch further. This is the condition for Condition for maximum stretch. Okay. This is the condition for maximum stretch. Okay. I can give you the velocity during that time. You can just conserve law of conservation of linear momentum along x-axis. In this case, mv naught is the initial momentum, and the final momentum is 3m times v1. That's all. So I have given v1. That's not. They're asking maximum stretch. You ask any question, my approach is C frame. In C frame of reference, the initial అరే వన్ స్టెప్ లో అయిపోతుంది, మీరు నోటీస్ చేయటల్లా. అదే మీరు రెగ్యులర్ గ్రౌండ్ ఫ్రేమ్ లో చేస్తే ఇట్ టేక్ లాట్ ఆఫ్ టైం. Actually, I have nothing to do with this relation. In fact, to answer this question, I require just one step. Now also half reduced mass m into 2m by 3m times v relative square is equal to that time there is no energy in the spring. When the spring is under maximum stretch, v relative is 0 because this is v1, that is v1, and a half k x max square, that is the maximum elongation. So with this I can confirm x max is root of 2m by 3k times v naught. That's the deal. 2m by 3k times v naught. One step, I have done the question. The only thing, then you may question me, sir, what is the role of this part in this question? Nothing. If you want v1, I can give you v1. That's all. Right. Next case is, you see, all are one-step problems. Almost one-step problems. All these questions are one-step problems. So therefore, this is an easy chapter for you actually, provided if you can go with the proper conventional step. Even now you see, same question. Do you wish that I need to do this question? Already we have done a similar question here. Already we have done a similar question here. The only difference is this question will have less number of steps when compared to that particular question. Same situation. This is the initial situation. This is the initial situation. What happens? When the slipping stops, both will have common velocity. V1, V1. So slipping stops. Both will have common velocity. In C frame of reference, the initial kinetic energy is V relative square. This is in C frame. Now, when they have relative velocity is 0, when both are moving at same velocity, slipping stops. Kinetic energy is 0. So whatever that the work done against friction is actually in C frame of reference will be the initial K. So I have simply applied work energy theorem in case of C frame of reference. In C frame of reference, this is the initial KE, this is the final KE, and this is the work done against friction. You want actually this. So I have done. So work done against friction is plus 3 by 8 mv naught square. If you want work done by friction, this is minus 3 by 8 mv naught square. Remember, this is a minus sign. So this is entire loss that converts into heat. heat dissipated. If someone questions, this is your answer. Okay? Right. Just please confirm me. Is there any doubt? Have you understood?
Yes, sir. No doubt, sir.
Right, right, right. Now, see, please try to understand all these problems. I'm using one single step. Law of conservation of linear momentum and energy conservation in C frame. Right. The entire chapter, law of conservation of linear momentum, deals with this particular
వచ్చింది మేడం.
theory only. Right. Next. Can you see the figure here? Figure shows a block A of mass 9m having a smooth semicircular groove of radius r placed on a smooth horizontal surface. Block B of mass m is released from a position in the groove where its radius is horizontal. Find the speed of a bigger block when smaller block reaches its bottommost position. No issues. Yeah, this is the initial position. This we will call as initial position. What is going to be the final position? My wedge is like this. This is going to be my wedge. And the block is going to be like this. Remember, this is your block B. This is a block B, whose velocity is VB. And this is the velocity VA. Right. Remember, two different velocities. Initially, there is nothing. There is nothing. Now, see, you have now two unknowns. One is VB, the other is VA. You have two unknowns. Right. Now, first, initially, there is no initial momentum along x-axis. So, apply law of conservation of linear momentum. You just apply law of conservation of linear momentum. 0 is equal to if a block is of mass block A of mass 9m having okay, the other one is of mass m, no issues. MBVB minus MAVA. Can anyone say why there is a minus sign here? Because B is moving rightwards, A is moving leftwards. So from this I can say 0 is equal to M times VB minus, okay, 9M times VA. So clearly I can say that VB is 9 VA. Done. So one part of the equation is obtained from this chapter concept. What about the other part? In C frame of reference, initially there is no kinetic energy and there is a potential energy mgr, because taking this as my reference, this is of height r. Right. Finally, half small m 9m by 9m plus m reduced mass times v relative velocity, which means VA plus VB. Remember, they are in opposite direction. So V relative square will become VA plus VB square. And remember, there is no potential energy because we will take this as zero potential energy reference. That is the reason why when taking this as the zero potential reference, the above height is taken as mq. Yeah, come on here. Control your voice. Right. Now I got M done. And finally, VA plus VB square is equal to, now what you got? 1 m I have cancelled. 9m by 10m. M will get cancelled here. 10. 10 by 9 RG. Right. Boys, don't forget, you know one relation like this. You have two unknowns, two equations. Now in the place of VB, put 9 VA. VA plus 9 VA square is equal to 10 by 9 RG, implies 10 VA is root 10 RG by 9. Now push this the other side. VA is RG by 90. Here if you take G as a 10 meter per second square, you can make it root R by 9. Then what is VB? VB is 9 times VA. So this will become root 9R. Okay. So finally, I have given you the velocities for these situations. But please take care that my steps were correct or not. 1 minute. I have applied law of conservation of a linear momentum. First step, and that I allowed me to obtain one equation. VB is equal to 9VA. Remember why I marked 0? Because everything is rest initially. There is no linear momentum along x direction. Remember here also I am applying law of conservation of linear momentum along x-axis. You are not allowed to use along y-axis because of weight. mg is an external force there. Right. Now, this is the initial stage and this is the final stage. So when the smaller block reaches the bottommost position, I am assuming that this has velocity VB and that has velocity VA. So in C frame of reference, initially the energy is mgr. Finally, the energy is purely kinetic. You know how to write Ke in C frame, half reduced mass times V relative square. That's what I have used. By doing proper calculation, cancelled, and I got 1 minute. 1 minute. Here I got this is a 10, 9 by 10, and I forgot this is 20 because a two term is here. 20, 10 into 2, 20 RG by 9, 20 RG by 9, 20 RG by 9. Okay, now 1 minute. When you push 10 in this side, it will become 10 square. So therefore, what you are going to get is, I suspected that there is some error. So I went back. That's the reason why. Now in this case, VA becomes root 20 RG by 9 into 100. 20 goes 5 times. That's all. So this will become root RG by 45. The calculation part, you please take care properly. If you are wrong even in one step, you are out. So do the rest of the question. But major caution is converting the initial to the final stage. I just want to check any student having doubt on this. Do any student have? Asrita, do you have any doubt on this?
No, sir.
Bhavita, do you have any doubt on this?
No, sir.
Nakshatra?
No, sir.
Right. This earlier also I have done, but still under the conditions of this chapter, I will deal it. Right. Everyone, please go through the question once. Seriously. Everyone try to please go through this question once. You can see here, we have two blocks A and B of mass M and 3M connected by an ideal spring. Here you can see whose force constant is K. Now both the blocks are given impulse in opposite direction so that they start moving with velocities V0, 3V0 as shown in the figure. Find the maximum stretch of the spring. Already last week we have done. Do the problem in C frame. In C frame, what is the meaning of maximum elongation? V relative is equal to 0 at maximum elongation state. In C frame, the initial kinetic energy is m 3m by 4m times what is the relative velocity? 3v0 plus v0 square. And there is no spring energy at this point. So finally, the spring energy is maximum, half kx maximum square. Because the kinetic energy is 0. Why kinetic energy is 0? I said V relative is 0. Remember all this in C frame of reference. In ground frame, kinetic energy can't be 0. Because if kinetic energy becomes 0, what happens is, see, please try to understand one relation. So when you are saying kinetic energy, you will usually write half mv square. This can also be written as mv square by 2m. This can be written as p square by 2m. So kinetic energy is p square by 2m. Remember, in a situation like that, the initial momentum is non-zero. In a system like that, the initial momentum is a non-zero. In this, initial momentum is a non-zero. Since initial momentum is a non-zero, final momentum is also non-zero, and finally there will be some kinetic energy in this. I mean, finally means during the time of maximum elongation. But in C frame of reference, our Ke is a function of V relative square. I told you very clearly, at maximum elongation stage, V relative is 0, means you see one block with respect to the other, it will be at rest. That's all. I have done the question. Cancel this. The x max is nothing but 3 by 4k m times 4v0 square under root. So you can write this as 1 4 will get cancelled. Still 1 4 will be remaining. So this will be 12 m by k times v0. That's x max. Okay, very simple, straight substitution type question. Right. Next. 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 Is right. I hope any doubts on this question, boys? Any doubt on this? Tejaswini, any doubt? Bhavana,
No,
do you
sir.
have any doubt on this?
No, sir.
Right. See, I am applying the same concept for all the questions. All the questions totally. A hemisphere of radius r and mass 4m is free to slide with its base on a smooth horizontal table. Particle of mass m is placed on the top of the hemisphere. Find the angular velocity of the particle relative to the hemisphere at an angular displacement theta when the velocity of the hemisphere has become v. What is that you are seeing is the initial condition. What according to me finally will be sometime later. Your hemisphere is like this. This is your hemisphere finally. And it has reached here. And let this be V relative. And by that time, it has displaced by theta. Right. Now, what is the situation as seen from the center of mass here? What situation you are going to face with respect to C frame? Before that, I require some work. See, this is we really to understood. The horizontally, we require components now. This one will have horizontal component as well as vertical component. This is theta, this is theta. And this is V relative cos theta. And by the way, this is V. Right. Good. Now see, actual velocity or velocity of particle with respect to ground. Let it be V1. See, velocity of the particle, the actual velocity of the particle with respect to ground. For example, I am taking that V1x component. This is with respect to ground. This is nothing but V relative cos theta plus. No, I am just defining what exactly I am writing about. Velocity of the particle with respect to ground is defined as velocity of the particle with respect to hemisphere plus velocity of the hemisphere. Right. So which clearly implies velocity of the particle with respect to ground. I am taking the x component only. Velocity of the particle with respect to hemisphere horizontal component is V relative cos theta minus V. Equation 1. That is the first part. One should take this into account. Now the second part. The second part which I need to take an account is this is V1x undoubtedly. And one more important point, V1x, right. One more important point is linear law of conservation of linear momentum you can apply. But remember, it is applicable only along x-axis. It is applicable only along x-axis. You said this is of mass of 4m and this is of mass m. So you just apply that m times V1x is equal to 4m times V. So I have a data V1x is 4V. Right. This is also an important data for me. You know why? I will explain. Now you apply law of conservation of mechanical energy. Remember, law of conservation of energy is different from law of conservation of mechanical energy. They are two different things. They are two different things. Law of conservation of mechanical energy, Ke plus P is constant. In law of conservation of energy, you can involve energy apart from mechanical, like for example, heat and other forms. Now, in this case, loss in potential energy is mg. Earlier, please try to understand where is the loss? Where is the loss part? Now, this is H, and H is R minus R cos theta. You know this already. So therefore, now you are applying law of conservation of mechanical energy. Loss in potential energy is mgr 1 minus cos theta. Now, gain in kinetic energy. There are two forms. One, the hemisphere V they have given in the data form. So therefore, no issues. Plus one more form, half m Vx square plus Vy square. Now, hold on. Now already you have Vx, which is a 4V. By the way, I just want to confirm, let this be equation 2. I'll use 1 and 2 simultaneously. So wherever I have V related to cos theta minus V, I can write it as a 4V. So wherever I have V related to cos theta, I can write it as a 5V clearly. So wherever we have V related to, we can write it as a 5V by cos theta. Bhaiya, just remember this, and I am maintaining for this purpose. This is equation 3. By the way, I have a clear-cut idea about V1x. What about Vy? Vy is nothing but this component, straight away. What is this component? Obviously, V relate to sin theta. That's the component. Now, according to law of conservation of mechanical energy, loss in potential energy is gain in kinetic energy. So, which clearly implies mgr times 1 minus cos theta is half 4mv square plus half m. By the way, Vx square, which is a 4V square. By the way, Vy is nothing but V relative sin theta. So which is nothing but 5V tan theta. 5V tan theta, which is 5V tan theta square. Right. That's all. That's all. By the way, what do you want right now? That's all. They're asking us angular velocity actually. So what is angular velocity? Omega is nothing but V relative by R. What is V relative now? Just now we have identified it is 5V by R cos theta. This is the other part. Remember, this is equation 4 and this is equation 5. Equation 4 will allow you to find cos theta term. Substitute that cos theta term in equation 5, you will get the desired answer. Right, but you can leave it here, no issues. Now the major, again, I'm just repeating the entire question again, just please follow. This is the initial system for you. The entire thing is at rest initially. At some point of time, when this one has velocity v, this will be moving with respect to the hemisphere v relative. At that time, this makes an angle theta. So the component in this direction is v relative cos theta, and the component in this direction is v relative sin theta. Remember, it has a fallen through a height h given by h is equal to small r minus small r cos theta, because this is r cos theta, total is small r. So the difference is small r minus small r cos theta. Right. Now you want angular velocity or velocity of the particle with respect to actual velocity or velocity of the particle with respect to ground. So honestly speaking, the velocity of the particle with respect to ground is given by according to the definition of relative velocity. Now we take only, see, there are two components here, x and y separately. I am taking only x component. I am taking only x component. When I am taking x component, what I will get? See, please try to understand what is this velocity of the particle with respect to hemisphere horizontal component. You know, this is V related to cos theta. Whereas velocity of the hemisphere, this is moving in the leftward direction with velocity v. So I should write this as minus v. Right, done. Now, law of conservation of linear momentum. Remember, I am applying this law of conservation of linear momentum along x-axis, strictly along x-axis, right? But in this case, what will happen? Just I'm applying m v1x is equal to, already you have given this as 4m, and you have given the velocity of this as v. So finally, I got this relation. And I have substituted that in this relation. So I got v relative as 5v by cos theta. Now remember, they want cos theta term also. I applied law of conservation of mechanical energy from this equation. You will get theta. Theta term you will get. But that is not what they are asking. They are asking omega. Omega is 5v by r cos theta. That's all. So jumbo problem, very lengthy problem, but still they are still under basics. I'm just asking you, have you understood this or not? Boys. Abhijit, have you understood? Abhijit.
Yes, sir.
Bhavita, have you understood this? Someone was raising hand. Yes, you can unmute and ask me your question. What is your doubt in this? Someone was raising the hand. Okay, no issues. Next. Hanvit, follow Inova.
Yes, sir.
Yes, sir.
Right, right. Yes. So now hold on. I left two models. Let me complete these two models and then we will proceed further. Don't worry, I'll post these notes. Those who have taken the printouts, we complete the notes today. Now, everyone, please go through the question here. Insulated glass jar, mass M, having an ideal gas of non-interreacting N molecules of gas molecules, maybe each having mass M, moves with a velocity V naught. Right. Random velocity of the gas called RMS velocity of the molecules in the jar is V bar. Then find the linear momentum. What do you want? Linear momentum of three terminals. One gas plus the container, which is called gas jar. What is this? This is nothing but linear momentum of center of mass of the system. Right. Will you hear any doubt? Any doubt? A very important step I have written. Right. Now, what is a P system? The P system is capital M, mass of the jar, total mass of the gas molecules into the velocity of the center of mass is V naught. Whenever they said V naught is the velocity, it is nothing but the center of mass velocity. This is the initial momentum. Right. Now, what is the kinetic energy of the system is what they were asking. Kinetic energy of the system is kinetic energy of the system is Ke C frame plus kinetic energy of center of mass. Already I have discussed that. I'll just show you that again. Here it is. Ke in C frame plus kinetic energy of the center of mass. That I'm applying here. Sir, why you are writing like this? Because with respect to the container, V relative square is nothing but V square. That's what you have given. Plus what is the K of center of mass? Total mass of the system. V center of mass. That's all. One single step. Actually, you may require this even in kinetic theory of gases also, but only for safe purpose I have discussed here. They may not ask you this question right now, but still, for safety purpose, I have done. But it is open to you. You can ask me any doubt related to this. Geetika, have you understood?
Yes, sir.
Akshaya, have you understood this question?
Yes, sir.
Right. One more question is left. Okay. Please go through. Already we have done, but still okay, fine. No issues. Less. This is our question. Already earlier, what is the difference between this question and the question which I have discussed here? No different methodology required. Same methodology. Two small disks of mass M1 and M2 are connected by weightless spring, right? Resting on smooth horizontal plane, and initially they have velocities V1 and V2. They are mutually perpendicular. Find the total energy E of the system with a reference to the frame fixed to the center of mass. Here, what is V relative right now? V relative is nothing but, okay, V relative is nothing but మైనస్ అంటే ఎవరిదో ఒకళ్ళది తీసుకొని చేసుకోవాలి. ఇట్ ఈస్ నథింగ్ బట్ మైనస్ V1 I cap plus V2 J cap. So what is V relative square? It is simply V1 square plus V2 square. By the way, what is velocity of center of mass? M1 V1 I cap plus M2 V2 J cap divided by M1 plus M2. That is velocity of center of mass. Okay, keep this with you. In KE frame of reference, in KE frame of reference, it is nothing but half reduced mass V relative square, which is nothing but half M1 M2 by M1 plus M2 times V relative square, V1 square plus V2 square. Done. Simple. First of all, in one step, I have closed this question. One step. Suppose if they ask KE in ground frame, you will simply write this as half M1 V1 square plus half M2 V2 square. Suppose if they ask you the maximum elongation in the spring, I'll simply answer it as KEC frame is equal to, I'll simply equate this to half KX square. That's all. I'll simply equate this to half KX square. Right. Any doubt? Bhavana, do you have any doubt?
No, sir.
Bhavana.
No doubt, sir.
Right. Shruti, do you have any doubt? I can see one raised hand. You can unmute yourself. Vijay Lakshmi.
No,
You have
sir.
raised your
Previous
hand.
question once. Can you explain, sir?
Right. You understood it, Vijay Lakshmi, clearly?
Yes, sir. Previous question I did not understand.
No. This one? You want this one?
Yes, sir.
No, very simple here. See, just now I have given what is the kinetic energy of the system. The kinetic energy of the system, 1 minute. In the last week class, you know, kinetic energy of the system is given in C frame like this. And K in ground frame is K in C frame plus this conversion factor, half M1 plus M2 VCM square. This conversion factor is required. Now, what I have done, I'll explain. In this, in C frame, C frame means nothing but if you are in a container like this, you see that the velocity is only V bar, V relative. ఇది V relative అని తీసుకో అప్పుడేమొస్తుంది half nm V relative square is this, right? Next part, K of center of mass. Just now we have done total mass of the system is this and total velocity of the center of mass is V naught. ఎప్పుడైనా V naught అని ఇస్తే for a system, it is nothing but the velocity of the center of mass. That I have written over here. That's all. I have just substituted in formula, Vijayalakshmi. I didn't do anything new. Honestly, okay, you may have a doubt. Sir, you are cheating. This is wrong. No, that is not wrong. I will explain. Actually, Vijayalakshmi, you got the correct point. I should have written it like this. Half Nm into capital M by capital M plus N small m times V relative square. This is what I should write. Here, M is very high when compared to the mass of the gas. The gas cylinder తీసుకుంటే hardly you find a difference between empty gas cylinder and a gas cylinder. But when I take a very big container, this is the condition. So in this case, this will reduce to Nm times V relative square. That V relative square itself is V square. That's what I have done. Vijay Lakshmi, have I given you a much more depth description now when compared to the previous
Yes, sir.
situation? Have you understood now?
Yes, sir.
Are you compromising still?
No, sir.
Okay, fine. Thank you. Maximum I have covered. Maximum. So actually, on the basis of law of conservation, we have only few problems. I'll deal first in this. Right. Yes. Go ahead. Two masses, A and B, having mass small m and 2m respectively, are kept on a smooth horizontal table, as shown in the figure. Okay. The mass B is given a velocity V perpendicular to the string, parallel to the table. Fine. Okay. Right. And the entire thing is on a table. Don't see that one is vertical, the other is it's not vertical. Actually, AB is on a table. Both are horizontally. And G has nothing to do here. First step, what I would like to suggest is where lies where lies the center of mass of the system? The mass is M. The other one is of mass 2M. And here lies the center of mass of the system. You know, the center of mass is at area totally L. So if this is R1 and this is R2, we know how to write R1. R1 is the other mass, M by total mass into total distance of separation, L by 3. In the other case, R2 is 2L by 3. So that is where your center of mass is. You have projected a 2m mass with the velocity v. So velocity of center of mass is going to be m into 0 plus 2m into v divided by 3m. This will become 2 by 3 times of v. Right. Now, this is the situation. Now, if you do the same problem in C frame of reference, I am now in C frame of reference. So I'll see that this one will be moving with velocity v minus 2 by 3v, which is nothing but v by 3. Whereas this is moving with 2 by 3v, because in fact you are moving with 2 by 3v velocity. This is in C frame of reference. Right. What do you want? Tension in the string. By you are in center of mass. So with respect to you, the entire system is rotating. So with respect to center of mass, this 2m mass is having a velocity v by 3. So now there is some tension T here and a pseudo force also 2m mv square by r. R1 is L by 3. Tension 2 by 3 mv square by L. Any doubt? It's a very standard question. N number of times you will be given this situation. Remember, this is ground frame. and this is a C frame. Vijayalakshmi, have you understood this question? Do you have any doubts in this question?
No, sir.
Pakka?
Yes, sir.
Right. Ashrita, do you have any doubt?
No, sir.
Anika, do you have any doubt?
No, sir.
Anvit, any doubt?
No, sir.
Hemant,
No doubt, sir.
because you are going to get n number of times. See, not necessarily the same quantum of masses and all that. Right. Three identical particles are placed on a horizontal smooth table connected with the strings as shown. The particle B is imparted a velocity V0 is equal to 9 meter per second, right? In horizontal, actually, addition direction, vertical, you see the entire thing on the table, which means actually this is a wrong picture. I will modify the picture because this picture is confusing you. Right? This is how you have the system. And they named this as A, B, C. Under such circumstances, they have given a velocity V0 the speeds of the particle A when it is about to collide with C, right? See, please try to understand one thing. This is the situation right now. That thereafter, what happens at some point of time, you will notice that right. Now you will see a situation like this. Remember, you will see a situation like this. Like this. When almost theta tends to 0, A will have Vx, C will also have Vx, and B will also have Vx. Maybe they may have Vy, Vy. Okay, that's the situation when they are about to collide. They are about to collide. A and C about to collide. Right, no issues. Still, I can apply law of conservation. Law of conservation of linear momentum along x-axis. It is this is in all the three are identical. mv0 is 3mvx. So vx is v0 by 3. Now, law of conservation of mechanical energy. Initially, total energy is kinetic. Finally, half mvx square 2 times half m vx square plus vy square. Here, you already have the data from equation 1 and let this be equation 2. So 1 in 2, you use it. So you will get half mv0 square is half mv0 square by 9 plus mv0 square by 9 plus mvy square. Cancel. Now finally, v0 square times 1 by 2 minus 1 by 18 minus 1 by 9 is vy square. Now LCM is undoubtedly 18. Okay. 9 minus 1 minus 2. You'll get v0 square is vy square. Boys and girls, 6 by 18. This will go 3 times. So therefore, vy is v0 by root 3. Vx is, boys, Vx is how much V0 by 3. I have given you the final velocities of A and C. By the way, what do you want? The speed of the particle A when it is about to collide C. Okay, fine. What is the speed of A? Which is nothing but Vx square plus Vy square, which is nothing but Vx square is V0 square by 9 and Vy square is V0 square by 3. Okay, so just solve this. You get 3 by 3. You'll get 2 by 3 V0. By the way, what is V0? V0 is a 9. So therefore, 2 by 3 times 9 gives you 6 meter per second. Very, very good question. Very, very good question. And I have done with fundamentals. Right. Varun, any doubt?
No, sir.
Right. Lokesh, do you have any doubt? The major problem what I face in conducting an online class, I'll explain. You people will start attending late.